So we go to the alkane section. So alkane section, there are a few components here. One, you talk about the homologous series. You need the properties of homologous series, and then you also need to know how to draw your different compounds. For you, D is not in your syllabus. Isomerism is not covered for you. So we can conveniently forget about it. So first, we need to know what are organic compounds. So we talk about organic compounds everywhere. It's like all day long, we talk, oh, that is an organic solvent, that is an organic compound. We used to do that very often in bonding when we talk about the physical state and etc. etc. So organic compounds are compounds that contain carbon. But these organic compounds, right, also contain hydrogen. They usually do contain higher carbon and hydrogen. Then there's a special name for compounds, organic compounds that contain hydrogen and carbon only. They are called hydrocarbons. But of course, not all compounds that contain carbon is an organic compound. So the compounds like carbon dioxide, carbon monoxide, metal carbonates, all of this contains carbon, but they are considered as inorganic compounds. You don't have to know what inorganic compounds is. You don't have to know the term, but you just need to know that they are not organic compounds. Earlier on, we have something called the periodic table. Can you tell me what a periodic table does? What information can you find from the periodic table? You can find the proton number, you can find the group and etc. Then can't hear metal,
The
non-metal.
mass number.
Yes, so you have all those. So the periodic table is a table that classify elements based on their properties, right? So they have different groups and different periods. If elements are in the same group, that means they have the same kind of chemical properties, right? So you have something like that in the periodic table called the periodic table. So those is one. Then you can think of homologous series as something like the group 1, group 2, group 3, group 4, group 5 in your periodic table. But this is for organic compounds only. So a homologous series says it's a family of organic compound. So it's like a group 1, now it has a name. So it has a general formula. That means you have a formula to represent everyone in a homologous series. Then all the members in the homologous series will have similar chemical properties because they have something called the same functional group. Then I'll tell you what a functional group is later. Okay, then there is another thing called they have a gradual change in their physical properties. Right. So physical properties are properties such as boiling melting point, whether they conduct electricity, etc., etc., right? All those things. I'm sure you are familiar with what physical properties are. So in a homologous series, their physical property change gradually. Okay. Then each member will differ from the next, right? By a CH2 group. This one you may not be familiar at this point of time, but just take note. So what is a functional group? Say a functional group is something like this. It appears in part of the compound. So let's say if you have a homologous series called alkanes. In alkanes, you will find that the carbons, right, are connected to each other with a single bond. So all alkanes will have something in their formula, something like this in the formula. So there is another homologous series called the alkenes. They will have the double bond. So if you see a molecule with the double bond there, they are alkenes. Then the next one, you have alcohols. Alcohols have this characteristic OH. So if you see OH at the end, then it's an alcohol. Then carboxylic acid will have this group, the COOH, not like this. And there's other thing called ester, which is not taught this year, is have this COO. Then all of them have a general formula. So that general formula will help you calculate the number of hydrogen inside a particular organic compound. Like they can say, what is the formula for a carbon 20 alkane or a molecule with 20 carbons, an alkane molecule with 20 carbons? Then what you do is you just take the formula here, C20, H is 2 times 20 plus 2. So it's C20H 42. Is it so? This is how you use the general formula. And or the recognizing the functional group in the molecule will tell you which family it is from. You will need this chart later. Okay, so this functional group will give the organic molecule a distinctive chemical property. So it will give the molecule a special chemical property that is very easy to tell apart from other homologous series. You caught me? Okay. So a lot of formulas are here. So what you do is after you substitute the number into the general formula, you get this formula here, right? This is also called the molecular formula. So what the molecular formula does is to tell you how many carbons are there, how many hydrogens are there, how many oxygens are there in the molecule. So ethanol has a molecular formula of C2H5OH, means that it has 2 carbon, 6 hydrogen, and 1 oxygen. Okay, so then this is called the structural formula. So like what you see down here, the drawing of the functional group, right? They are actually found in your structural formula. So let's say this one is the structural formula for ethanol. So the structural formula shows how atoms are covalently bonded to another, how atoms are covalently bonded to another atom in the molecule. So ethanol, it looks like that. So I will scrutinize if there's any special group. See, there's an OH here, which is the same as this one, the OH here. So it means that it's an alcohol. So this is an alcohol. Okay, so naming wise, I will just do a quick run and then we'll revise this again the next time. So unlike the elements in the periodic table, the names are not not unique, but not recognizable. You can't look at the name of the element and tell which group it is from, right? But organic compounds, right, by looking at the name, you can tell how many carbons are there in the molecule, and you can also tell which homologous series the organic compound is from. And then you will find the name very familiar because if you look at food labels or shampoo labels or hair conditioners or facial wash, you will see names of all these organic compounds are lying around on the labels. So you can go and look at it later. I mean, you can go to your bathroom and take out soap and then you can see the chemical formula down there or the name down there. Okay, so an organic compound, the name consists on 2 parts. So this is the name of the organic compound. So yes, so there's this thing called the prefix, and then behind there's this called the suffix. So the prefix tells you the number of carbon atoms in the compound. You have to remember this, but I think some teachers will tell you remembering up to 4 will be enough. So I just included more. There's actually, we used to study up to 10. So I included 6 here. Then if there is a need, I will put some more behind if you need it. Okay, so prefixes. So any organic compound that has METH, okay, in front means that it has 1 carbon. So if you have ETH, then it's 2, then PROP is always 3, etc. So then, yeah, ethanol. So propane. Ethanol, yes, propane, So you see, ethanol, let's see ethanol. Ethanol is an alcohol, and then we have ETH means it's 2 carbon, and then you see 2 carbon here. Okay, so then there is a second part, which is the suffix. The suffix tells you which homologous series is from. So if it ends with ANE, that means it's an alkane. ENE means it's an alkene. OL means it's an alcohol. And then this is carboxylic acid. So back to ethanol just now. So it was C. It looks like this. OH. Okay. So how we derive the name from this is you see that there are 2 carbons. So ETH. Then you see OH means it's the functional group for alcohol. So it's an OL. Then you get ethanol. ETH. Then the AN. Yeah, you can use ETHAN also. Then I think it's better to remember. So that's that. So make some guesses on here. So name this organic compound. This is 1 carbon. So what should the prefix be? So 1 carbon, if you check, is this. Then there's only single bond, so it's alkane, so like that. Then second one, we know this already, this is ethanol. Then this one, you look at the functional group, this is it's an acid, so we have this. Then we have three, so it becomes propanoic. Then this is, you see a double bond, so it's a ENE alkene. Then you have 1, 2, 3, 4. So if you check your chart, it will be BUT because there's 4 carbon. Okay, so then you're gonna do this. So for this is this. So then you are to state which homologous series it is from. And then they are need to give a reason for your answer. Make a guess. So you just need to name the compound and the homologous series. Okay, let's identify how many carbons are there. It's not alcohol, you have this. It's not alcohol. Alcohol is like that only. So you have COOH. So I bring that file back for you. So COOH.
Carbolic acid.
Carboxylic acid, this one. So carboxylic acid, then where's my prefix and suffix? Here. So 2 carbon, so it starts with D. Okay, acid, so
Atonic acid.
yeah, so
Atonic acid.
so it's a carboxylic acid. So that is the homologous series.
Atonic acid.
Okay.
Why is it big? Why is it capital H and O?
Typo.
Then the rest are small letter.
Typo. Then the name is ETHANOIC acid. So unless you do,
then they say give a reason.
because it has the COOH functional group. Reason it contains the
COOH.
COOH functional group. This one, C3H7OH. Come back to this again. Remember, C3H7OH. Which one is it?
Alcohol.
C3. Which one? 3 carbon.
Alcohol.
Yeah, 3 carbon. You have to name it.
Pro.
Okay. Then OL, right? So that means this one is the alcohol. Then it is like that. Then it, because it contains this functional group. This one you must know. This one important. 3 carbon again. So it's this. So which functional group?
Alkene.
Then ends with ENE.
Propene.
Then the reason is because it contains the functional group. Okay, this one shows a condensed chemical formula. What this is, right, is I can redraw. It's alkene, yeah. So we can redraw. This one means it's CH3 here, CH2, 2 groups of CH2, so like that. And then the last one like that. So you redraw, you can draw out the structural formula in this way. So this one, CH3, CH2, CH2, and CH3. So then become like that. These 2 groups they put together. So this is how you convert from condensed chemical formula to the full structural formula. So it's alkane. Then there are how many carbons? 4. So 4, that means it will be this alkane. That means A and E. Right? So if you want for answer, right, then you can say it contains carbon single bonds. Okay.